Okay, with question 3, as soon as you see mass, density and volume, you know that you're dealing with this triangle. So, if you're working out the volume, if you use this, if you cover up the V, volume is equal to mass over density. If you want volume, you cover up the V for volume, is equal to mass over density. So, volume is equal to mass over density. Common mistake from here would just be to go, right, the mass is 12.5, the density is 19.3, I'll just do 12.5 over 19.3. You get a mark for that because you are showing that you know that volume is equal to mass over density. But because this is in kilograms and your density is in grams per centimetres cubed, we can't really combine them and use this formula yet because our units are different. So if I instead think of this as being 12,500 grams, remember that K means 1,000, so that's 12,500 grams. Then, once my units match up, so that's grams and this is grams per centimetres cubed, I can say my volume is equal to my mass divided by my density. So, if I do that, can't see the calculator very well there, 12,500 divided by 19.3 gives me 647.668, etc. Give your answer correct to 3 significant figures. So, I'm allowed to use 3 numbers, which means I have to limit it to this. The mark scheme says an answer in the range of 647 to 648, but really to 3 significant figures, because the next number is a 6, it's 0.6, that is closer to 648. So be careful, because I've put a box around 647, that might make it look like I'm saying that's the answer. It's not. To 3 significant figures, that rounds to 648, not 647. Question 4, let's have a look. So, the ratio of the number of blue pens to green pens, so let's try and keep this organised. So, blue pens to green pens is 2 to 5. The ratio of the number of green pens to red pens is 4 to 1. Now, if I can get the numbers that represent the green parts here to be the same, I can kind of combine these 2 ratios. So with 5 and 4, if I make this one, for example, 8 to 20, just by timesing both sides by 4, and I make this one 20 to 5, just by timesing both sides of this by 5, because the green parts are now 20 in both, I can combine these and I could have a ratio that is blue to green to red. Because that 20 is common now, I can do 8 to 20 to 5. Now, if this is the ratio, it's possible that you could have exactly 8 blue pens, 20 green pens and 5 red pens, which gives you a total of 33 pens. Or, that ratio is actually the same, it doesn't change. An equivalent ratio, if I timed all of this through by 2, that now gives me 66 pens. The question tells you there are less than 100 pens in the box. Let's keep going. If I find another equivalent ratio, if I times all of this by 3, that becomes 60, that becomes 15. They all now add up to 99 pens. If you go any further than that, it will go past being 100 pens in the box. So this is the highest you can scale up your ratio. And if you read off then, the greatest number of blue pens is 24, the greatest number of green pens is 60, and the greatest number of red pens, which is what the question asks you, is 15.